Of chapter 6 deals with inequalities. Can anybody give me an example of what an inequality is? Anybody know what those are? An inequality? It's not equal, right? So how do we represent something that's not equal? What are the symbols for that? Something that's not equal. Equal is the equal sign, not... Okay, so we have an equal sign with the slash means not equal. What about if I want to show something that's not equal, but I know if it's more than, less than, something like that?
The crocodiles.
There you go. We have these symbols. These are all called inequalities, right? What do those stand for?
Greater than, less than.
Good. Yeah, greater than, less than, greater than or equal to, and less than or equal to. Now, a couple things I want to know in the notes is I want you to first date them. So have the date. So I have the date up here on the screen, the January 6th. Okay. And if you want to put the topic, you can put inequalities on there. Okay. So we need to label which one's which here first. One that's this way. When you're looking at it from left to right, which one is that? Greater. That one is greater than. Right. Okay. So the other way would be less than. That way. I will check them occasionally. You won't turn them in every day. No. Greater than or equal to. And then you have less than or equal to. So these are all inequalities. These are what we're going to be working with today. Okay. So instead of solving equations, things with equal signs, we'll be working inequalities. Now, so you always look at it going from left to right. Like, for example, if I was going to make something that was true here, I'd put like, this would be true. 5 is greater than 3, right? That would be a true statement. You always read from left to right. 5 is greater than 3. Okay. The other way, 2 is less than 4. That would be a true one. Remember, or equal to, things can be equal, and that would remain true. So we first have to recognize what's true and what's false. So looking at those, I think we can do that. Yes?
What would be less?
This would be a true statement because 2, it's not less than, but it is equal to 2.
So it doesn't matter which one you put it on?
So it would just be true. True. No, if they were the same number, both of these would be true because it's all equal to. Right. Yep. Good. The thing we want to know how to do, which a lot of you have probably seen this before, is how do you represent, like if I said x is greater than 2, what numbers could x be? There's an infinite amount. What's one? What's one number?
1.
Could be 4. Could be, what could x be? What could x be? 8. 9. 6. 100. 10, right? So we got all these answers that x could be here, right? We need a way that we can write all of those numbers without having to write them all out, right? Because writing them all out is impossible. You would start with 2.000000001 eventually and keep going, right? Because this would work, there's an infinite amount of possibilities, right? So one way we write those numbers is on a number line. So you guys remember a number line goes on forever and it just starts somewhere like this? Right? That's a number line. I just picked some numbers to start with. So would 2 make this true? If I plug in x is 2, is that true? Is 2 greater than 2? No, it's false, right? 2 is not an answer to this problem. But 2.1 is, 2.2, 10, 20, 30, 40, 100, a million.
90.
Those are all 90. Those are all answers to this problem, right? So we need a way to write those on the number line. So first we have these things called open and closed circles. You guys remember talking about those? You guys talked about those? Okay. On this number line, we want to put all the things that are greater than or equal to 2. Or sorry, just greater than 2. So that's all the numbers on which side of 2? All the numbers to the left or all the numbers to the right?
Right.
It'll be all the numbers to the right. Those are all the ones greater than, right? So the way we do that is we will put an open circle and then we will draw an arrow to all the numbers in that direction. Because 3 would work, 4 would work, 5 would work, 6 would work, 6.5 would work, 7 would work. All these numbers would work over here. They would work for x, right? Would any numbers on this side work? No. And the reason this circle is open, what I mean by open is it's not filled in, is because 2 would not work. Because if you put 2 in here for x, that's false. That's not a true statement. So this is the way we represent those numbers, or we represent these inequalities. So let's look at another one here. Let's say I gave you this. X less than or equal to 7. So I'm going to make a number line. Now remember, on your number line, it doesn't matter where you start. Let's say I'm going to start with 6 here, and I'll go down this way. But it always needs to get bigger from left to right. Means it needs to get higher numbers here, and it needs to go smaller numbers here. Just like the way you would read, right? It needs to read from left to right, greater numbers. So this says x less than or equal to 7. So I want all the x's that are less than or equal to 7. So would 7 work in this problem if I plugged it in for x?
Yeah.
It would, right? 7 would work. So that means I'm going to put a closed circle or a filled-in circle for 7. Because 7 would work. 7 is what we call included in this answer, or it's included in this problem. Okay? And then let's just test the problem. Would 6 work here?
No.
Would 6, when I plug it in for x, is 6 less than or equal to 7? Yeah, it is, right? Would 5 work? Is 5 less than or equal to 7? Yeah. Would 4 work? 4 less than or equal to 7? Yes. All the numbers on this side make that true. All the numbers on this side make it false, right? 8 doesn't work. 9 doesn't work. 10 doesn't work. 100 doesn't work. So this is the solution, or this is how I represent all the numbers x could be. Okay, that's the first thing I want you to know about inequalities. Any questions with that? This is putting it on a number line. All right, I'm going to have you try this one now. Okay. I want you to put this one in your notes at least. If you put the other ones, great. Now remember, your number line, it always needs to get bigger as you go towards the right. So it should look like this. Now if you didn't go all the way to -5 or didn't go all the way to 1, that's fine. I want you to put this on a number line. Put x, whatever symbol this is, -2 on a number line. I'll give you a second to try that. So first, I'm going to go to -2. Is -2 an answer for x? Could -2 work?
Yeah.
It could, right? Because -2 is greater than or equal to -2. And remember, if it's an answer, we fill it in, because that means it's included. That means -2 works. So then I want all the x's that x could be, so it's greater than -2. So which side of -2 are those answers on? Are they on the right or on the left? And they are on the right. Because -1 would work, that's greater than -2. 0 would work, 1 would work. 100 is going to be way out here somewhere, right? 100 would work, 200 would work. Everything in that direction would work. So we put an arrow there. So this is how we represent those numbers. Yeah.
So how do you know if it's open or closed?
If it's open, circle would be either greater than or less than, and a closed circle means it's included. That's going to be or equal to, one of those two. Open circle is going to be just greater than or just less than, because that number is not included. Closed circle is going to be greater than or equal to or less than or equal to, because that number is included. Okay. All right, I want you to try this now. Any questions on this? Please stop me if I go too fast or anything. I want you to put that on a number line. put that on a number line. On the same number line. X greater than or equal to -2 and x less than 4. So let's just think of quick answers off the top of my head. Would 0 work for this problem? Is 0 greater than or equal to -2 and less than 4?
No.
It works for both, right? Yeah, because 0 is greater than or equal to -2 and it's less than 4. So 0 would be an answer. Like 1 would be an answer. But would 20 be an answer?
Yeah.
20 is greater than or equal to -2, but it's not less than 4, right? So I want you to put this on the same number line, but only cover the numbers that would work for both. So let's see if you know how to do that a second, and then I'll give you a minute to try. With your number line, you can put anything you want there. Just remember, it has to go bigger as you go towards the right. So like if I did 0.
Can you like start at the left and just go up 1, 2, 3, 4?
Yeah, that's fine. But you need to be able to put -2 and 4 on the line, so you need to at least go that far. So the way we're going to do this is we're going to do it one at a time. So let's first look at the left one. It says x is greater than or equal to -2. So that means at -2, are we going to put an open or a closed circle?
Close.
Closed, because -2 works, right? We're going to put -2 there. And we want all the x's. All right, so to solve for x, what do we do to both sides?
Plus 3.
We get rid of the -3. We add 3 to both sides. So we would be left with x greater than or equal to 5. So now we put this on a number line. Okay. So there's my number line. I'll just put 5 somewhere in the middle since I know I'm going to be on that one. And I'll go bigger as I go towards the right, smaller as I go towards the left. Is on 5, is it going to be an open circle or a closed circle?
Close.
Closed, because it's or equal to. Because 5 is an answer to this. 5 is greater than or equal to 5, so that number is included. So then I need to figure out which way includes all the answers so that x is greater than or equal to 5. If I'm unsure, just pick a point and test it out. Let's test out this point. If I plug in 6, is 6 greater than or equal to 5? Yes. Is 7, 8, 9, all of those numbers that way are, so that would be it on a number line. Because 4 doesn't work. If I plugged in 4 there, 4 is not greater than or equal to 5, so I wouldn't go to the left. I would have to go to the right. Okay. Any questions on that first part? All right. We're going to do a quick iPad activity here.